summer months are sneaking up on us pretty fast now. And you're probably cleaning up the fishing tackle and golf clubs so you'll be ready for them. We need to get ready for some air conditioning service, too. Of course, you technicians in the warmer climates have been at it for a while, but stay with us, because we have some new information for you. Oh, hi, Frank.
Hi, Tech. What happy chance brings you to our shop today?
It isn't all chance, Frank. I stopped by to see what you picked up at the air conditioning classes last week.
Well, for one thing, I learned that there was a lot I didn't know about the new units. In fact, I was just about to go over them with Jack. Why don't you stick around and keep me straight?
Thanks for the invite, Frank. Where do we start?
Well, Frank's already told me that we have 2 new factory-installed units on some of the 65 models, and that we have some production changes on them since the start of the model year.
That's right, Jack. I call the 2 units Type A and Type C. Type A is available as a factory-installed unit on the Dart, Valiant, and Barracuda models. Type C is available, factory-installed, on Plymouth Furies, Dodge Polara, Custom 880, Monaco, and all Chrysler models. The refrigeration systems for the 2 units are basically the same as previous systems, so we won't need to cover them completely. Let's take a look at the air distribution systems and how they operate in combination with a heater. On the Type A system, installed in Darts, Valiants, and Barracudas, a single blower serves both heater and air conditioner. This new unit supplies fresh outside air to the air conditioner as well as to the heater. Airflow is controlled and directed through the unit by a series of doors, which are opened and closed by vacuum actuators and 1 Bowden cable. The heater water valve is also vacuum operated.
Isn't the water valve adjustable to get more or less heat?
Not on this unit, Jack. The water valve is either closed or full open, depending on the position of the controls.
The amount of heat is regulated by controlling the airflow through the heater core. Here's how it works. Pushing the heat button applies vacuum to the rod side of the fresh air door actuator to open the door, and to the back of the defroster door actuator, which closes off the defrosters, except for a small bleed opening. A third vacuum line goes to the rod side of the air conditioning door actuator, which closes off the passage to the evaporator core. A T connection in this line provides a vacuum source to open the water valve. With the doors in these positions, all the air entering the cowl ventilating panel passes through the heater core, blower, and heater outlet ducts. This is the maximum heating position when the blower speed switch is on high.
The blower is turned on automatically when any of the air conditioning, heater, or defroster buttons are pushed. Pressing the off button closes the fresh air door, opens the air conditioning door, and turns off the blower and water valve.
Thanks, Tech. Defroster operation is the same as heater operation, except that vacuum is applied to the rod side of the defroster door actuator opening the door. About 70% of the heated air goes to the defroster ducts. The other 30% goes through the heater openings.
It must be that the temperature is regulated by controlling the position of the fresh air door.
Not so fast there, Jack. There's one door Frank hasn't explained yet.
Right, Tech. It's called the blend air door. The blend air door is opened and closed by a Bowden cable connected to the temperature control slide lever. When the lever is all the way to the right, in the full heat position, the blend air door closes off a passage that bypasses the heater core, so all the air goes through the core. As the slide lever is moved to the left, the blend air door opens. This routes part of the fresh air directly into the blower without going through the heater core. So, heated air from the heater core is mixed with cold air coming through the blend air door opening. The mixture of cold and heated air, which is regulated by the position of the blend air door, determines the temperature of the air at the heater and defroster outlets.
How about fresh air ventilation? If I push the heat button and move the lever all the way to the left, all the incoming air bypasses the heater core.
That's partly right, Jack, except for one thing. The heater water valve will be open and the core will be hot. Some of this heat will be radiated into the airstream, so the air at the heater outlet will be a little bit warmer than outside air. Fresh air ventilation using ram air is available by opening the summer air door on the right end of the unit and the cowl vent door at the left front side of the tow pan. Be sure to close these doors, though, before the air conditioning is turned on. Now, how about the air conditioning, Frank?
The Max AC and AC push buttons operate the air conditioning portion of the Type A unit. The heater slide lever also controls the amount of cooling, and the heater blower switch is used to control blower speed. When the heater and air conditioner are both turned off, engine vacuum closes the water valve and holds the air conditioning door against the heater outlet. It also holds the defroster door and the fresh air door closed. The recirculating door, operated through mechanical linkage, is held open by the same actuator that holds the fresh air door closed. When one of these doors is open, the other is always closed. When the Max AC button is pushed, the switch closes the electrical circuits to the compressor clutch thermostatic switch and the blower motor. All the doors remain in the same position as when the unit is turned off. Since the fresh air door is closed, all the air going through the evaporator core enters through the recirculating door. Blower speed is increased beyond the normal high speed to get maximum airflow.
How do we get the extra blower speed?
When the recirculating door opens, the door linkage closes a bypass switch. One of the resistors is bypassed, increasing the voltage to the blower motor.
On early production models, the bypass switch is operated by the air conditioning door linkage. Both types are covered in the reference book for this session.
The AC button puts the fresh air through the evaporator core by opening the fresh air door and closing the recirculating door.
How does the blend air door regulate air conditioning temperature?
It doesn't, Jack. The amount of cooling is controlled by the temperature control switch in the compressor clutch circuit. The switch is regulated by a Bowden cable attached to the blend air door bell crank. Here's how it works. A gas-filled sensing tube from the switch is inserted into the evaporator housing. As the sensing tube changes temperature, the gas contracts or expands, acting on a diaphragm inside the switch. A spring, controlled by the Bowden cable, acts on the other side of the diaphragm. The force of the spring against the diaphragm is increased as the slide lever on the instrument panel is moved toward the warm position. When the gas in the sensing tube contracts, as it's cooled by the evaporator, the spring pushes the diaphragm to the left, opening the switch to disengage the compressor clutch. A small amount of adjustment is provided for the control switch Bowden cable. The mounting tab screw hole is elongated to permit some repositioning of the cable.
When you're making that adjustment, make sure you hold the temperature control switch cable all the way to the left and the blend air door closed. There are a lot more tips and procedures in the reference book for this session, so be sure to look it over carefully.
I sure will, Tech. I've learned that checking the manuals, bulletins, and reference books can prevent a lot of trouble. Now, how about the Type C unit?
We'll talk about the Type C in just a minute, Jack. Right now, I see it's time to turn the record.
In the Type C heater air conditioner, the heater water valve is cable operated by moving the temperature control slide lever in the instrument panel. The heater water valve controls the discharge air temperature during the operation of both the heater and the air conditioner. This is the basis of the reheat principle of air conditioning. All the air entering the system passes through both the evaporator and the heater core, regardless of whether the air conditioner, heater, or defroster buttons are pushed. Chrysler, Dodge, and Plymouth all have different titles on the heater air conditioner buttons. To simplify the explanation, let's use the Plymouth Fury titles: Off, Max, Fresh, Heat, and Defrost. When the heat button is pressed, vacuum is applied to the rod side of the air conditioning actuator and the fresh air door actuator, and to the back side of the defroster actuator. The fresh air door actuator moves the door against the recirculating opening allowing fresh air to enter the system. As in all other Chrysler-built units, the blower is turned on when any one of the control buttons is pushed, except the off button. As we've already said, all the air passes through the evaporator core, but since the compressor clutch is not engaged, no cooling occurs. The air conditioning door is held closed, and the heater door is opened by the air conditioning actuator. So, the heated air is directed down and then forward under the opened heater door and out through the openings in the bottom of the housing.
Some of the heated air goes into the defroster ducts. A rod attached to the air conditioning doorbell crank pulls the defroster doors open slightly as the air conditioning door closes.
Thanks, Tech. Does any air come from the heater openings when the defroster button is pushed?
Quite a bit, Jack. Pushing the defrost button changes the vacuum application from the back of the defroster actuator to the rod side, pulling the rod downward. The other vacuum applications are the same as for heater operation. As the defroster lever is forced downward, it contacts the heater door lever and carries it down against a spring load toward the closed position. The heater door doesn't close all the way, so about 30% of the air bleeds out through the heater openings.
I noticed that the defroster door linkage has a slotted adjustment in the middle. What's the adjustment for?
That's what determines how far the heater door will be open. Right, Frank?
Right, Tech. To make the adjustment, press the heat button. This closes the air conditioning door and puts the defroster doors in the heater bleed position. Then, loosen the adjusting screw and push both ends of the link toward the screw to take all the free play out of the link. Tighten the screw and push the defrost button to make sure the heater outlets are bleeding off some of the air. There's a sensing unit in the lower part of the heater core housing that acts as a thermostat. It's a liquid-filled tube that varies the water control valve opening slightly to maintain an even temperature in the core.
What's the story on that valve set up on the face of the heater core? It looks like it's operated by the air conditioning door.
That's a good guess, Jack. How about it, Frank?
A real good guess, Tech. That's a water bypass valve. Anytime the air conditioning door is open, the valve is closed. Here's why. When either of the air conditioning buttons is pressed, the compressor clutch is engaged and stays engaged until the driver turns it off. So the refrigeration system always operates at full capacity. To control the amount of cooling, the heater core reheats the refrigerated air. The amount of reheat depends on the position of the slide lever, which operates the water flow control valve. The water bypass valve shuts off the flow to 70% of the heater core. The remaining 30% of the core is used to reheat the airflow. This reheat type of air conditioning provides the most comfortable car cooling available. The maximum refrigeration removes most of the moisture from the air, even on very humid days.
That's why it's very important to keep the evaporator drains open. On this Type C unit, there are two drains. The Type A system has only one drain, near the center of the unit.
Thanks, Tech. I'll make a note of that. How about the airflow for air conditioning?
Coming right up, Jack. It's real easy to follow. When the max button is pressed, vacuum is applied to the back of all three actuators. This opens the air conditioning door and the recirculating inlet and closes the heater and defroster doors. When the controls are changed from max to fresh air conditioning, the fresh air door actuator vacuum is switched to the rod side. The door moves away from the fresh air inlet and closes the recirculating inlet. Pushing either air conditioning button turns on the compressor clutch feed and the blower feed to the resistor block. The blower's speed depends on the position of the speed switch. A resistor bypass switch is closed by the air conditioning actuator. When the switch is closed, one of the resistors is removed from the blower circuit.
On this unit, the bypass switch increases blower speed in all three speed switch positions. In fact, you can increase blower output during heater and defroster operation if necessary by soldering a permanent bypass jumper around the resistor. Attach the jumper between the two bypass switch connections in the resistor block. But don't ever put a permanent bypass jumper on a Type A unit.
Thanks, Tech. That's a good tip. Here's another one. You may run into a condition of severe window fogging when the heater is turned on. This is caused by intermittent use of the heater and air conditioner. To avoid the fogging, advise your customer to operate the air conditioner for about a half a minute before turning the heater on. This will blow the moisture out of the air conditioning outlets rather than on the windshield. If you have to recharge a Type C refrigeration system, you'll need to increase the amount of R12 called for in the air conditioning manual. Add an extra 4 ounces on single units and an extra 8 ounces on dual units.
You'll find the new capacities in the reference book for this session. It also includes a few other changes or revisions you want to make in your manual.
I'll be sure to check it out, Tech. How about antifreeze requirements?
I'm glad you brought that up, Jack. I found a little confusion among some of the other men. Cars equipped with Type A or cool air systems don't require antifreeze protection for the heater core during the summer. On all other cars, antifreeze protection down to plus 15 is enough to protect the heater core during summer months. But it isn't enough to provide corrosion protection for the engine cooling system. To provide adequate inhibitors, add enough antifreeze to take the protection down to 15 degrees below zero.
We have just about enough time for a couple more service tips before we run out of time, Frank.
Okay, Tech. One thing you should always check on a complaint of insufficient cooling is the expansion valve thermal bulb. Make sure it's inserted about 5 inches into the well and the rubber seal fits tightly. Another one to watch out for is the routing of the thermal bulb capillary tube. Some tubes have been found to be rubbing against the carburetor air cleaner or the ignition distributor. Eventually, the tube could wear out, requiring replacement of the expansion valve.
We're running out of time, Frank, so let me get in a few final words to all the master technicians. Last session we talked about the value of special tools and pointed out some of the more valuable ones, including your manuals and torque wrenches. I'd like to add another valuable tool to the list: your knowledge of the operating principles of the components you service. The more you know about the units, the easier it will be to diagnose any difficulties that may arise. So study your manuals, bulletins, and reference books. You'll be mighty glad you did.